Hi and welcome along to the second part of the online training for Swyx and the authorization course, and in this module we're going to take a quick look at ISDN and how we connect it to Swyx. So let's quickly go through some of the principles. ISDN is the Integrated Services Digital Network. It can carry both voice and data. And ISDN lines consist of a collection of bearer channels that carry the payload, the voice or data, and a single signaling channel. And the signaling channel will contain information about the caller, the DDI number, CLI information, etc., etc. The bearer channels are always 64K, so the only type of voice that ISDN carries is G711. And the signaling channel, which is a 16K signaling channel, carries, as I said, all the other information about the caller, the type of call, etc., etc. And the type of ISDN interfaces, well, we have two types of ISDN available on the Euro ISDN standards. We have the ISDN2, also known as basic rate, and also known as 2B plus D. Two bearer channels because it has two 64K channels, two simultaneous voice calls, and one data channel. So we can carry two concurrent calls, but we can have multiple numbers on a single ISDN circuit. There are also two ways of presenting ISDN2 trunks. It can either be point to multi-point, in which case you have a bus type configuration, something like this, where the network comes in and you have multiple devices sitting in parallel across that bus, terminated with a 120 ohm resistor at the end. Each of these devices can be used independently. They all have their own multiple subscriber numbers, so they can all be called directly, but of course with only two voice channels there can only be two speech calls, or one speech call and one data call at any single moment in time. That's typically what you will have got in very small offices a long time ago. Obviously, in the world of PABXs, you probably want something a bit more sophisticated, and that's where we get to a point-to-point connection, where you have one point of entry into the building, that's ISDN2 in this case, feeding a PABX, and you'll have multiple lines. And in this scenario, you see three lines on the screen. Each line is an ISDN2 line, so there are two channels on each, so there's 6 voice calls that can be handled concurrently by the telephone system, and the telephone number can span across all 6 channels, whereas in the case of point to multi-point, the numbers can only exist on one particular bus for obvious reasons. So ISDN2 or basic rate or BRI or 2B plus D all mean the same thing and has two ways of presenting itself, point to multi-point or point to point. Then we move on to ISDN 30 or PRI or primary rate. ISDN 30 has a maximum of 30 bearer channels. In the UK we do offer fractional ISDN, and it starts with a minimum of 8 channels and grows to a maximum of 30. Elsewhere in Europe you get an ISDN 30 and you get 30 channels in some countries. ISDN 30 can only be in point-to-point, note that. Always designed for a PABX, never designed for a bus type operation. So that's the two types of ISDN. It's also interesting to take a quick look at the way it's presented on the sockets. So ISDN2 comes into your building and will be terminated by the network provider onto the network termination equipment, or the NTE. It's an RJ45, 8 wires of course, and the two pairs that we use for ISDN are a transmit pair and receive pair. The other spare pairs carry 48 volts as standard. There's zero current there, you can't use it for anything. That's the pinouts on an ISDN2. And that will terminate into, our case, into Swyx. And of course, built into the system, we need to cross over those cables. The network talks on the transmit pair to our receive pair, and our receive pair vice versa. Big difference on ISDN 30 is the pins used. It's the blue and orange pairs, so 1 and 2 are the receive pair and 4 and 5 are the transmit pair. But likewise the same as ISDN 2, those pairs are crossed over within the hardware. Transmit talks to receive and vice versa. ISDN works in 2 modes. We talked about this on the first training course, and there was a short video on that. TE mode, terminal equipment, it's a telephone or a PABX, fax or something like that, or NT mode where you're connected to other equipment. There is a consequence of doing this, and we'll cover that shortly in the next couple of slides. If the port's connected directly to the network, to the telephone service, it must be in TE mode, but if you want to hang a telephone system or other equipment off of us, you have to put it the other way around. To make that clear, you'll see a slide coming up that we have to actually cross over the transmit and receive pairs, but hopefully I'll make that clear a little bit later on. Let's talk about installing the cards though. So there are a number of ISDN cards in our portfolio. We have a quad BRI card, so that's 4 ISDN2 circuits. We have a single PRI, that's a single ISDN 30, or a dual ISDN 30 card. So 3 cards in the product range. We only support European ISDN, or technically DSS1. The drivers and the installation of the cards is exactly the same, regardless of which one you're doing. But before you put the cards in, there are some jumper blocks on the cards, and that's what we're going to discuss in the next couple of slides. Once you put the cards in, boot the system up and get the driver off of the DVD. That's available on the downloads. The only ISDN cards we support are the cards that we supply, the SX2 models. A couple of things you have to be aware of though. You can only put 5 ISDN cards in a single piece of tin. That's not really a limitation these days. You don't find many servers these days that have got 5 empty slots on them. Be aware though that if you go for the dual PRI card, that is equivalent to 2 cards. And the other thing is you can only have a maximum of 76 active channels in the gateway. As usual, knowledge base articles 3159 if you want to read up more about those and those limitations. Our cards are all PCI cards, and as I said, we have the SX Express Quad, that's the ISDN2, and we have the single and dual card. They do not work in PCI slots, obviously. There's a picture, the SX2 Quad BRI. 4 sockets on the back of it, 4 RJ45s for 4 lines, 8 channels. And as can be seen on the right, from the top view there, a number of jumpers and dip switches, which we're going to discuss now. So just before we get to actually put the card in the slot, switch things on, it's important that we set the card up with the right jumper settings, because trying to fiddle these on a live machine, well, it's virtually impossible. So let's look at the situation where we're going to be most of the time. We have the telephone network providing an ISDN, as on this slide I showed you earlier. The transmit and receive pairs are configured by the system, so you just have a standard Cat5 lead, and the transmit and receive pairs are swapped over by our hardware. But if we move things around now, and Swyx is now providing the telephone line into a sub PBX, well, if we left the Swyx hardware as it was, our transmit and receive pairs would be configured exactly the same way as everyone else's telephone system, so they couldn't talk to one another. What we actually need to do is reverse those pairs over, so our receive pair and transmit pairs are swapped over, so we can emulate the network. Could do it with a crossover cable, of course, but no one makes those. Anyway, we have some switches to do that for you. So those 4 jumpers that are highlighted in red there, each one associated with adjacent RJ45 socket, they're actually labelled TE and NT mode. If you won't be able to see it on that picture, but if you actually see the card, it is screen printed on the card itself. So if all the jumpers are to the right per socket, then that particular socket is set for TE mode. If they're all to the left, they are set to NT mode. But all these jumpers are doing are changing the pin outs of the sockets. They're swapping those pins over. They do not change the mode of operation of the card. To change the card from being TE, a receiver, to a transmitter, then you have to go into the device manager and the driver, and we'll see that shortly. So the jumpers on an ISDN2 card, all they do is change the pinouts of the RJ45 to cross over the transmit and receive pairs, so we're compatible with NT or TE mode. Also, next to each of those set of jumpers, there are a pair of dip switches. The dip switches are used to add the 120 ohm termination resistor at the end of the bus, as per diagram on the earlier slide. That diagram also showed that there are 48 volts on the unused pins on the RJ45 supplied by the network. We don't supply that as standard. If a piece of equipment plugged into our card it's absolutely vital that that equipment has the 48 volts, then we do offer a optional power supply module which inserts that 48 volts. So very occasionally you'll come across a piece of hardware that does require that 48 volts, and there is that optional power supply if you so need it. We also have a clock synchronization to keep all the cards in perfect sync with one another. Particularly useful if you want to do data and it's vital that you keep the channels in sync. Then we have these two sockets where you can run a ribbon cable out and in between the cards to ensure that they all run in synchronization. There are more details about that in that knowledge base article 3161. To be quite honest, doesn't get used an awful lot today. Most devices like video conferencing are moved to IP. But if you do need more information about that, please refer to the knowledge base article. Here's a picture of the ISDN 30 board. This is actually a dual board. Like before, it has two sets of jumpers here for NT and TE mode. We also have an additional jumper here. The additional jumper is used to set the board up for our standby mode. With that jumper in place, this is a 30 channel board that allows power fail or failover in the case of a master standby scenario setup. There are no 120 ohm termination resistors, of course, because there is no bus mode on here, and we still have the synchronization, the clock synchronization sockets at the top there. So going back to this failover master standby jumper in there, if that's in place, it's a 30 channel board. If you take that out, it's just a dual ISDN 30 card, takes 60 channels into the system. Where it's used in master standby is in this sort of configuration, and that's why the card ships with the jumpers in NT and TE mode differently. You take the ISDN in from the network into this socket here, and then you put a standard Cat 5 out of here into the standby machine. While the master server is live, these two sockets are separated from one another mechanically by these four relays. In the event of a power failure, or in the event of one of the services failing on Swyx, these relays drop and the ISDN is automatically patched through to the standby server. So when you have master standby, the idea is, should the master server fail, all the users are automatically logged on to the standby server and you don't have to repatch the ISDN because it's done for you. Another thing we need to quickly discuss is the PCM switching. So we have this clock synchronization cable that links multiple cards together, and in the scenario where we have, for example, an ISDN 30 coming into the building into one of our ISDN cards, and then we have an ISDN 2 card also in the system, and it delivers ISDN 2 out to a video conference unit, for example. By default, the system will route the calls and the data between the two cards over that ribbon cable. It will not go via the Swyx gateway service. And the advantage here, as I said, we're going to keep the cards in synchronization. The clocks are going to be locked together. We won't need to put any echo cancellation in because it's all done by hardware. So PCM switching is where we switch the lines through the cable. The downside of PCM switching is there's no recording. So if you're doing a a sub PBX, that part of the call won't be recorded. Doesn't matter, you can record on the other card. If I want to change the PCM switching, then all I have to do is go into the advanced settings in the driver, and then we get the option to do this. Again, doesn't get used an awful lot. You can read up on the knowledge base articles and find out more information. When you go into the driver, by the way, here's what the driver looks like for an ISDN2 card. I know it's an ISDN2 card because it's got 4 ports. When you first open up the driver, you'll know whether there's a PCM wire connected or not. As you can see in this one, it's not. And to be perfectly honest with you, I've only seen this installed 2 or 3 times in the last 10 years. The advantage of using our card to drive ISDN out, we call it NT mode. Other manufacturers and other engineers refer to this as a BRI bus. You can connect ISDN phones, not a lot of advantage in that. Sub PBXs, yes, absolutely. Put Swyx front side of another telephone system. Group 3 fax via a AB adapter, no, wouldn't be needed these days. Modems. Should someone need a modem? Yes. If you remember back to the first part of the training course, our analog adapters do not support data devices. So you could get an ISDN2 to analog adapter, put it into our ISDN card running in NT mode, and then plug your modems into that. There's a valid use for that. Be aware, of course, no power supply, as we said, and supplementary services. Supplementary services, basically when I put a caller on hold on an ISDN device and then transfer it, I'm actually going to trombone the call up and down the bus. Supplementary services allow you to put the call on hold back to the exchange or back to the equipment. We don't support. On the back of the card, along with the 4 sockets in the ISDN2 or the 1 or 2 sockets on ISDN30, you will see some 4 LEDs. These relate to layer 1 and 2. Is the trunk connected? Is there any data on it, etc. And if you want to look at the lights, there's the information for you. So let's quickly look at the driver now. So the drivers can be found on the DVD in the hardware directory. Once you loaded the car and loaded the driver, you will find the card listed under network adapters in your device manager, and when you go into the ISDN card, you will see something that looks like this. So if we go to the ISDN2 tab to start with, the type of ISDN2 listed here should say European ISDN DSS1. If it says anything else in there, problem is probably you've got the operating system language and region set up incorrectly. So if you see something from AT&T, Bell or something like that in there, you need to change it. We only talk European ISDN. If you hit the configure button, you'll see this dialog box come up. Under no circumstances should you put anything in there. That is no longer used and irrelevant today. That will just cause you problems if you do go into it. So next I want to look at the Advanced tab in the driver, and particularly by pressing the ISDN parameters button, we'll see this. So here we're looking at an ISDN2 board, quad controller. I can see 4 controllers in there, but it looks exactly the same for ISDN2 or ISDN30. It's just the number of controllers changes. And here I want to go to the Line Access tab. And in the Line Access tab, if it's ISDN2, you'll see this point to point and point to multi-point. The card will default to point to multi-point. 99 times out of 100, the circuits provided to you today will be point-to-point lines, so you will need to change this. Another word of warning, if you upgrade the driver at any time for the ICN2 card, you will need to go back in and change this, because on a driver update, the line access is always set back to point to multi-point. And we mentioned earlier about the dip switches changing out the mode from NT to TE. Well, they don't change the mode, they change the pinouts. Here is where you go in and change the TE to NT mode of the card, or of the controller itself. Not the card, it's done per controller. So that's the physical part of the card. We do give you a piece of test software on the DVT called the D channel monitor, or DCM for short. The DCM is a bit like Wireshark for ISDN. It's a protocol analyzer, and it shows you the messaging that are going on. It shows you the D channel so you can see the numbers, etc. Great for diagnostics, absolute must finding any faults, or if you've got problems with configuration, check that the network are actually sending you the right info. So when you start the D channel monitor for the first time, a selection box will come up asking you which controller do you want to monitor. You can run the D channel monitor multiple times and run multiple circuits all at the same time. You'll have lots of information on the screen, but you can do that if you want to. In this case, it's a dual ISDN cards, ISDN 30 card that's come up, and we can select the controller we want to look at. Having selected the controller, we'll see this box, and it's split up into 3 sections. We have the header, the D channel header, and you get general information about the system. Down the left hand side, we can actually look at which layers we're going to be monitoring. Now, ISDN follows the 7-layer model. So layer 1 is the physical layer, layer 2 is where we're getting the handshaking, the clocking, and layer 3 is where we're getting our messaging. Now, on an ISDN2, very quiet ISDN2, this information will be scrolling up at a fairly leisurely rate. On a busy circuit, and particularly on ISDN 30, this screen whacks up at one hell of a rate, and you won't be able to keep track of it. So everything that you see scrolled up on the screen is actually saved to this log file, which can be found in the traces directory in Swyx. So quickly show you what you'll see on the screen there. Layer 1, the physical layer, it's green, it's activated. If you see layer 1 deactivated and it's red, it means it's not plugged in. It's quite simple. What you can't see here are layer 2 messaging. Layer 2 messages are handshake messages, so every 10 seconds, in the UK anyway, every 10 seconds you'll see a message coming from the network provider saying, "Are you there?" and we respond instantly, "Yes, we are." So you'll see that on layer 2 every 10 seconds. I just want to quickly show you a simplified version. I've taken a lot of the intermediate steps out of here, but an overview of what you're going to be seeing in the D channel monitor. So go back a slide. This information here, the yellow section here. Basically what we have here is the U stands for user, and the N stands for network, and the arrow is the direction of the communication. So we're looking at a incoming call. I know it's an incoming call because the message has come from the network to the user, and it's a setup message. We respond the setup message with an acknowledge, and then the network will send us information about the caller and the CLI information, etc. We send a call proceeding, which is, yes, I've received the information. In this particular case, we've then routed the call to an extension, and the extension is ringing, and then we're sending the ISDN alerting message. If you remember back to the first part of the training session where we talked about how calls were delivered, and the ISDN message is sent back to us when we receive that ISDN message, or when another piece of equipment receives the alerting message, they will generate ringing. Other messages you could get there obviously are busy or fault, etc. Anyway, we sent back an alerting message, and then we get a connect message. So this is the guy's picked up his handset. So we see the call started, first presented to the system at 11:37 and 52 seconds, and at 11:38 and 8 seconds the guy picked up his handset. The network acknowledged that, and now the speech is happening, and the speech is happening on one of those bearer channels. The data channel hasn't got anything to do now, so you can see there's a massive jump from 11:38 to 11:43 where we get a disconnect message. During that period, this call was in speech. They were talking using one of the bearer channels, and there was nothing for the data channel to do. 5 minutes later, the call hung up, and this disconnect message came from the network. So the inbound caller disconnected the caller. It wasn't disconnected by Swyx, and there is nothing that Swyx can do to affect these inbound messages. The D-channel monitor is talking directly to the card. It's not talking to Swyx. It's talking direct to the hardware, and it's monitoring live what's on the channel. So there's nothing we can do to affect that. So the outside caller disconnected the call at 11:43. We release, and the network releases it. And that's a simplified version of call flow in ISDN. For those that know SIP, you'll see the call flow is actually very similar to SIP, and we will be covering SIP in another module. Under each one of these headings, these information elements that you're showing on here, there is further information, and there are a couple of pieces of information that you may want to look into. The first one is this information element, calling party number. This is the CLI information of the inbound caller. If you do not see the information element calling party number, it's because the network provider has failed to switch it on, and it's something that they need to do at their end. If they have switched it on and you see the information element calling party number, and you're still not seeing the telephone number on the screens, you will see why here. In this case, we got presentation allowed. If it says presentation withheld, caller has withheld their CLI information. And then just to confirm it, you'll actually see the digits that they're presenting to you. The second information element is the called party number. This is the DDI number. In the UK, the DDI number is usually a 6-digit number, but it can be different. And it's absolutely important that we know that it's 6 digits, because by default, when we set up the software later on, we do the number plans and program the system, we will be looking for a 6-digit number by default. If the network is sending us a 4-digit number, so years and years ago, I can remember old Panasonic phone systems only ever worked with 3-digit DDIs. If you've taken out one of these really antiquated systems and replaced it with Swyx, and the network is still providing 3 digits, we will not respond to those messages because we're looking for a 6-digit number. So if you have problems, going in here, looking at the called party number and checking the number presentation from the network will save you time later on. And we'll discuss that when we come to programming the trunks in the network later. Well, that's it for this short module on ISDN. Many people think that ISDN is dead. No, there are areas of the country that still cannot get good enough bandwidth and quality of service data voice calls, so they still need ISDN. And there is a wealth of ISDN equipment out there that customers still want to carry on using and needs to connect to us. So that's why we still cover ISDN. Next modules coming up, where we got SIP and some other stuff before you come on the training course. As usual, if you've got any questions, please contact us, drop us an email, and we'll get back to you as soon as we can. Hope to see you on the training soon. Until then, take care.